Now, there's an inextricable link between the stars and the map, right? I call it between the celestial sphere and the geographic graticule, because latitude and longitude are inextricably linked to the sky and the stars and the time and sidereal time, right? You could look at a star, you could take an azimuth, meaning directions, 0 being north, and you take a 360-degree reading from there, and that's your azimuth, and then an elevation angle, which is just its angle of incidence above the horizon. If you take just an azimuth and elevation angle of any star, then we can tell you where you are on the graticule. So I put it into where I'm at, about, let's see, Massachusetts. Here, let's try here. Yeah, Massachusetts. And I'm going to look up. I'm going to find this star. I'm going to run my program on this altitude and elevation. So this is in, right ascension and declination, but let's convert that. Let's do quickly the program here. So we'll give it a run, and we'll say it's at 45-ish azimuth, and it's at 54-ish degrees. And today is 9/24, so 2024. Was it months? So 9/22, and it's 2/13, 14/13. Now that gives us a plot of the ground position of the star that I just saw. So what that is giving us is this, right? So what it has just by an azimuth and elevation of a star, when I look a little bit north, so here it is. And it gives you the ground position on the graticule of where that star is. Now, the time is necessary because you will have to know when it's going to be over a certain point. Like when that ground position is going to rotate depending on its lattice around the circle. Essentially, this dot is going to rotate around here. Depending on the time is when it's going to stop over here. So this is where I saw it. This is what the ground position is. This is where it is relative to me as I'm over here. And this is why there's such a link between the sky and the map, right? There's no one measuring the ground, mind you. We're just finding our position relative to the stars. And this, I think, should prove it. Right? As we just showed, at any point, one of these stars will give you the exact location where you are on the Earth. It doesn't have to be right ascension declination. There's a direct conversion happening for right ascension declination to long lat, right? So here's what it looks like on the AE map. Imagine the continents are here, right? If I drew them in here, then this would just rotate around and you would have the time when you would see the star. So here it is, all right? And then here would be it moving. So just imagine, this is why the time is necessary. None of these stars ever change latitude. If a star appears at this latitude, it will appear at this latitude for everyone. The only thing that will change is the time, and the time gives you the position of the ground position of the star, which is why right ascension and declination and right angle hour ascension conversion are necessary, right? The stars are everything. The stars are the backbone of longitude, latitude, backbone of the grid. They're the backbone of everything. If we use the stars to measure the stars and then compare them to the stars, it's always going to come up stars, right? This is essentially why it's important. This is what they've mapped out. All they've done is look at the sky, take a good map of it, and then they've given us the corresponding points on the ground. Now, because the sky is in a dome shape, we see it in a hemisphere. When you match the ground to it, what shape does that force the ground into? Of course, it would necessitate sphericity. So that's where, in my opinion, all sphericity comes from.